Now we are coming to the very popular technologies, which is nowadays getting more and more acknowledgement as compared to the previous RO plants, these desalination plants, especially for the water in the water treatment and the wastewater treatment. That is the membrane technologies. In membrane technology, you can see this is RO plants to remove the salt content and the contaminations, dissolved contamination from the raw water. And this is a picture of the modules of the ultrafiltration. Well, I will discuss the ultrafiltration and what is the difference between these modules and why and where these are installed. Before going into that, you must understand that what is the phenomena of reverse osmosis? Osmosis is the process in which from, suppose if you give you a very easy example, if you have a glass of water and put a drop of ink into it, blue ink, you will see the ink is a concentrated version of the solute, and it will start dispersing in the water. Similarly, when you put 1 spoon of sugar in the cup of tea, you have to stir it to mix. That means a osmosis process goes on so that we have a uniform distribution of all the ingredients in the solution. Normally, in osmosis, that is it is a movement from higher concentration to low concentration. And these in the reverse osmosis, what we do is by building the pressure, we put the module, give the high pressure, so that solute is on one side, which is water, and the high TDS goes to the other side. From one side, we feed the water, and other side, we have 2 streams. One is the product stream, which will be having low TDS or almost maximum reduction of TDS depending upon the feed water quality. And other is the brine stream, reject stream, which will be rich of the salts. You can see these are the terms which we use, and that the permeate flow divided by the feed flow. What product we are getting divided by feed into 100, that is called the recovery of the system. Salt passage, the permeate salt concentration, how much salt we have in the permeate, TDS we have in the permeate, how much we are feeding in the water. That into 100, it will give you the salt passage. And salt minus, if we can, from the salt passage feed minus product, we can get the salt passage in the reject as well. That is the basic thing which you need to understand. Now, we will discuss the type of membranes available in the market and on which the R&D is going on. And the microfiltration, these are basically cross-flow membranes. And every membrane, this is a molecular sieve, like you want to sieve the any molecule from the liquid which is dissolved. As in case of water, we have sodium chloride, calcium, magnesium, sodium in various form, calcium carbonate, calcium sulfate. Every molecule have a different molecular weight. Suppose water has 2 H molecule atoms and the 1 oxygen atom. Its total molecular weight is 18 and its size is smallest. The second bigger particle is sodium chloride. Sodium chloride, sodium has a 23 grams molecular atomic weight, and the chloride has a 35.5. Total is 58.5 grams per mole is the weight of sodium chloride. In case of water, smallest molecule is of water, which has the H2O, 18 molecular weight cutoff size, and the second is sodium chloride. That is why all membranes of RO, they are tested on the sodium chloride, that how much they have rejection capacity. All membranes are tested on the rejection of sodium chloride. When you will see the data sheet of RO membranes, they will show you the rejection of sodium chloride. That's 99.7%, 8% or 2%. That is how they are tested. Yeah, just I wanted to clear your concept that these microfiltration, ultrafiltration, nanofiltration, and RO membranes, they have the different pore size. These membrane has the different pore size, and based on those pore size, we select that what we want to separate. If we want to separate the suspended solid, we will go for the ultrafiltration membrane or the microfiltration membranes, because we know that the microfiltration and the ultrafiltration membrane will remove the suspended solid as they are visible with the naked eyes. In the nanofiltration membrane, we suppose if you purify the dye or the sugar or some bigger molecules, then we go for the nanofiltration membrane. Basically, there is the term which is used, molecular weight cutoff size. The molecular weight cutoff size, as the molecular weight of any molecule, as I've explained, in water, we have the 18 molecular weight, and sodium chloride, we have the 50, 23 and 35, 58.5. The size of each molecule will increase. So based on the molecular size, which is we call the molecular weight cutoff size, we select the membrane if we want to go the partial separation of any molecule. And these membranes have a wider application. They have the application apart from the RO, nanofiltration, ultrafiltration, microfiltration membrane. They are available with different molecular weight cutoff size, and you can use in the dairies, juice purification, tomato ketchup, and skim milk, and even in sugar industry. And these are the lot of applications of this membrane technology. Inshallah, we will cover when this module comes. And now, just to give you the idea about how the membranes work, various membrane works. Okay, let me have a glass of water, please, if you don't mind. Okay. Microfiltration membrane, just see. As I have told you, that all membranes have a different molecular size, and you can see in the microfiltration, ultrafiltration, and RO membrane. When we install the microfiltration membrane, it allows to, it's like a sieve. You just visualize that in your mind. It's like a sieve. It will pass the water molecule. It will pass the monovalent ions, like you have a sodium, potassium. These are the monovalent ions. They will pass. Multivalent ion, they will pass. It means all TDS will pass. Virus will also pass. And only the bacteria and the suspended solid, these will be rejected. They will go in the reject stream. If we go for the ultrafiltration, water will pass. Remaining all three monovalent and multivalent ions, they will pass. And only the virus, additional feature is ultrafiltration membrane. They will remove, in addition to the microfiltration membrane, virus as well. Virus, bacteria, and suspended solid. And if we go for the RO membranes, they will only allow to pass the water. And a monovalent, all TDS, monovalent mean all, it's a cation, anion, which we have in the water, all they'll be removed, bacteria, virus. And frankly speaking, if you want to directly use the water for the ultrafiltration, from the ultrafiltration, you don't need to have the ozonation or the disinfection process unless you store water for certain duration, because if your plant is working perfectly, your virus and bacteria, they'll be removed, and there'll be no biological contamination in the product water. And same is the case with the RO water. You don't have the bacteria, virus, and the suspended solid. And these are the difference. And we can use this just for it's a simple slide to make you guys understand about the membrane technology. This is the filtration spectrum. You can see here, this is the size of the pore size. This is the, you can see molecular weight. Water, as I told you, has 18 molecular weight. Sodium chloride has a 58.5. And likewise, other, if you see as the molecular weight increases, its size will go bigger. When the size will go bigger, it will not pass from the pore. RO membrane you see here. Okay, from your now you can see the RO membranes reverse osmosis. You can see we can remove the particles or the ions or the molecules having signs 0.001 micron. And if you correlate its molecular weight, cutoff size come up to be 200. This is the size of the molecule. You see, as this range, you can have antibiotics, soluble salts, insecticides, some dyes, this metals, and the sugar. This will show you that where we can have which membranes application. For the sake of argument, for the ultrafiltration membrane, which have a bigger pore, 0.01 and see, you can remove up to 20,000 molecular weight, the particles, which I have explained during the previous slides. You can see algae, bacteria, and these are the application. From here, you can just understand that which membrane is selected for the which type of removal.